All right, Unit 8, Section 6, Angle Relationships in, on, and outside of a circle. So we have another theorem. If a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is half the measure of its intercepted arc, which makes sense. You can see the diagram there to the bottom right. But all we have is an angle on the edge of our circle. We talked about that in the last section, where, if this arc was 100, the angle would be 50. It'd be half of that. Something we've kind of already talked about, but now it's saying two specific, a tangent and a chord, two specific vocabulary words, I guess. All right, so an example. If we have a tangent and a chord meeting, which we do, right here, we have angle 1 formed. So if the arc is 172, the angle would be half that. So half of 172 would be 86 degrees. And then if you want to find the measure of angle 2, which of course would just be the other way, you probably first want to figure out your arc measure. So you take 360 minus 172. You get 188 degrees. So this is 188 degrees out here. So angle 2 would be half of that, or 94. All right, so we talked about central angles to begin with, and just a reminder, a central angle is where the vertex is at the center, and if this was like 41 degrees, the arc was also 41 degrees. So just keep that in mind, because we have central angles, we have inscribed angles, angles whose vertex is on the center here, and then let's just call that the measure of the angle, measure of angle 1, whatever. The measure of the angle is going to be half whatever our arc out here is. I mean, you knew that. We did that in the last section. Let's call it angle 1. Let's give it a number. Angle 1 there. Okay, so the two new cases today are if we have the vertex inside of the circle or outside the circle. The two formulas are very similar. So if you want to find the measure of angle 1, and I labeled it 1 there for you, all you have to do is you have to take 1/2 of arc A plus B. So you add together the opposite arcs. So here's arc A, here's arc B. You add them up, divide by 2. Or if you would like this version better, like I said, you add them up, divide by 2. Either way, that'll get you the measure of that angle. And then I guess, so you might be asking yourself, how do I know that that's angle 1 and that's not angle 1? Well, it really doesn't matter because they are vertical angles, so they should be the same regardless. So we'll call that angle 1. Doesn't matter, just because it's a bigger space to write in. All right, if we have a angle whose vertex is outside of the circle, so we'll call this one right here angle, well, I better do this. Angle 1 is going to be right in there. Okay, so if that's our angle and we want to find the measure of angle 1, we're going to take 1/2 of A minus B. So now this one's, it's important you get the order correct. When you are inside of a circle, you just add them up, and you know that addition order does not matter. Here, though, you're subtracting, so you're taking the farthest away arc, the bigger of the two arcs, and you're subtracting the smaller arc in here, and you're dividing it by 2. So you could do that way, or you could go measure of angle 1 equals A minus B divided by 2. However you want to look at it, it's all saying the same thing. All right, so what is the measure of angle 1? So you first need to ask yourself, is my angle inside the circle, on the circle, or on the center? Because now we're going to kind of put it all together. hopefully you know the angle is inside the circle here. So if it's inside, if you don't know, look back up here for a second. We're looking at this case right here in the middle. So you're going to add the two arcs, divide by 2. So the measure of angle 1 equals, and again, order doesn't matter when you add arcs. So we're going to go 120 plus 98 and divide that by 2. Goodness. So we have 218 divided by 2. Squeeze that in there. So it should be 109. All right. So you can see problems like this where it's pretty straightforward, or you can see some where you have to kind of solve and find missing pieces. So in this case, we have a vertex on the outside of our circle. So in this case, you would, if I scroll back up, you would subtract the big arc minus the small arc and divide it by 2. So here's our big arc. Here's our small arc. But in this case, we already know the angle measure, but we still want to set everything up the same. So you always start with your angle, the measure of angle, whatever. 1 is usually, I guess, what we're calling it. But we know the measure of that angle. It's 45. So 45 equals, then you take your big arc, 170, minus your small arc, x, and you divide that by 2. So now we're going to solve for x, which means we got to get x by itself here. So we will multiply both sides by 2. So 90 equals 170 minus x, because that's going to get those denominators to cancel. We're still looking to solve for x here. So we will go ahead and subtract 170 from both sides. Goodness. So that's going to cancel. Sorry, negative 80 equals negative x. And then divide both sides by negative 1. X equals 80. So you can see we can set these up to solve here too. But the setup is going to be the same. Just make sure you know, I like this form personally. If you like the top form, that's up to you. But just make sure you know those 3 things. Central angles are pretty straightforward. Let's calculate some values with variables. So you really have to understand the setup first. So you have to figure out, is my vertex inside, outside, or on the circle? In this case, we're outside, so you're taking the big arc minus the small arc. So my angle, 61 degrees, equals my big arc. Here's my big arc. 10x plus 1 minus the small arc, which is 5x minus 1. You're dividing that by 2. So let me get different colors. So 61 equals, let's combine some like terms. So 10x minus 5x would be 5x. 1 minus negative 1 would be the same thing as 1 plus 1, so 2. Okay, so we combine like terms. We can multiply both sides by 2 here. So 122 equals 5x plus 2, because that's going to cancel out the denominator. Subtract 2. 120 equals 5x. Divide both sides by 5. X equals 24. So there you go. Like I said, you got to understand the setup first, and then you can plug in the information, find the missing piece of information, whatever variable or whatever parts it's asking you to find. Now calculate the values of x and y. So here it really doesn't matter. We have everything we need. Let's just start with x because x comes first in the alphabet. So here's x. It is an angle, however you want to look at it, with the vertex inside the circle. So in this case, your angle equals, and then you just add together the opposite arcs and divide by 2. So 171 plus 77 is 248. Divide that by 2. And you get 124 degrees. So there's x. When the vertex is inside the circle, it's pretty straightforward, or on the circle. Now y, you're going to have to do some visual work here to see y, but y goes all the way from here to here. This is the very first thing we looked at today and in the last section. So we have an angle with a vertex on the circle, which means you find the measure of the arc and you divide it by 2. So 171 plus 30 is 201. I guess I should probably write that out. So y is 171 plus 30, and then we're going to divide that by 2. So 201 divided by 2 is 100.5. And that is it. So the hard part is going to be keeping straight what kind of angle we have. A vertex on the inside, vertex on the outside, a vertex on the circle, or a vertex at the center. But that will take care of Unit 8.